Good afternoon and welcome to the National Gallery's last Facebook Live for this year's Science Week. My name is Joseph Padfield. I'm a conservation scientist here in the National Gallery, and today I'm going to be presenting along with my colleague Florian Cargoli, and we're going to be talking about some of the aspects of light and what we do with light within the scientific department and generally within the National Gallery. We're going to be using this fantastic painting here as a backdrop and as an example for the lights. This is The Rape of the Sabine Women by Peter Paul Rubens, which is a 17th century painting. And we are actually in the conservation studio within the National Gallery, and this painting has been undergoing examination and treatment. So it happens to be in the room, so we can actually use it as a backdrop for this discussion today. Now, what we're actually going to be talking about is the lights that are used in this room. So within this room here, the conservators need to study the colours that are in the painting and examine exactly what's going on in the painting. So they need very good quality light to be able to see the paintings clearly. So for many years they've been working with a set of lights we have hanging from the roof here, and they're based on fluorescent lights, and effectively we have a bank of daylight equivalent fluorescent bulbs, and these can be used to illuminate the paintings. Now these are a fixed light and they have been very useful, but there has been some discussion over the last few years to look at how we can examine improving the quality of light. Now light, as hopefully many of you will know, can come in lots of different colours. I mean, it's the difference of when you're home and you turn the light bulb on, when you come home, it will look a lot warmer or yellower than perhaps the light would when you go outside during midday. And obviously sunsets and sunrises, you get different colours. And you can see from these paintings up here, hopefully, that the fluorescent bulbs are a daylight equivalent. They're a much sort of whiter, bluer light than the lights we have behind, and it's the lights we have behind here that we're going to be talking about more in a second. But they are more equivalent to a candlelight type sort of amount of light there relative to the daylight equivalent bulbs here. Now, what we want to talk about is the difference, is that anything we look at, I mean, you may have actually bought a piece of clothing in a shop and then wanted to take the piece of clothing near the front door so you could see how it would look like under daylight. It's because objects look different under different colours. And what we'd like to do is to make sure that when the conservator is working on a painting, the light that they are using is the best quality we can actually provide them. Now, if we actually look at these two lights, these old fluorescent tubes are a fixed fluorescent light. And what we want to move to, and what we're testing at the moment, are these new lights here that can actually change. There's a difference. So at the moment, as I said, there's quite a warm light, but we can change it, Florian, if you can change it to the daylight, you can actually see, there we are, we can actually change what's called the colour temperature of these lights. We can change how they appear. Now, this is achieved by a lot of complex technology that's been built into these systems that have been developed as part of an EU project called HiLED. And the actual lights themselves have been built by a company called Ledmotive that we've been collaborating with to test these lights and test the prototypes of them over the last few years. And basically the way it works is that instead of having a single light source inside them, each one of these light units actually have 10 different LEDs. And each of these 10 LEDs are a slightly different colour, right the way across the whole rainbow that you get within white light. So we start with the blues and the violets right the way across through the rainbow to the reds, and the yellows and the greens and the blues to capture the whole rainbow. And effectively what we can do is we can change how much brightness you get from each of these colour LEDs, just like a recipe, and you blend them all together to create a different type of light. Now, as you saw before, these won't change. Now, if we're going to turn off the fluorescence and then concentrate just on these LEDs and how they look on the painting. So if we actually sort of concentrate more on the painting now, if we move back to the candlelight next one, we can see that you have a much warmer appearance of the painting under an equivalent of candlelight. And now obviously you're viewing this through a mobile phone, and there's a lot of issues to do with how the camera will capture it. And obviously there's a lot of daylight in this room as well. But as we start moving up and we're increasing the colour temperature, so this is candlelight, and then if we move to a tungsten bulb equivalent, you can see that that's a lot lighter. The colours start to come out a lot more. There's less of a sort of golden hue against the painting. Now, if we move to the next one, which is equivalent to a cool white fluorescent light, we can see that the blues start to jump out a lot more. The difference when you're changing from these colour temperatures is that you start to increase the balance of blue to red, and you give a more even light. So actually you start to see the colours coming out more and the balance changing. And if you go to the daylight equivalent, Florian, And you can see that there at that point, the daylight, the bulbs are actually matching the daylight we have in the room. So again, we have quite a good balance. So effectively, when a conservator is working on a painting, they want to ensure that the daylight that they have to work on, that normally comes through the windows, is well matched by the lights they're using. Because obviously when we put the paintings back down on display in the main galleries downstairs, most of the light we work with is daylight. So we want to ensure that the paintings actually will consistently look the same. And when you're actually trying to restore or adjust small damages within paintings, you'll be actually putting in little bits of colour to match the surrounding colour. Now, some of these colours, as I explained before, they will look different under different lights. So we need to be able to make sure that the conservator can see that the pigments that they're using will appear the same as the pigments they're trying to match. And this is why actually having more control of the lights is incredibly important within this type of environment, with this work. So we've agreed, as I said, in collaboration with the HiLED project to start testing these lights, and they've just been installed here in the conservation department in the last couple of weeks to see how we can use them and how we can actually develop, help develop the technology for the future. Now, I'm going to let Florian take over a bit here, and you can see some of the complexity, because obviously each of these lights are effectively now a small computer. So they take a lot of controlling. Florian?
Exactly. So now I'm going to show you how I can control the light. So it's through my computer. There is like a dedicated interface. And as Joe said, each light of the module is composed of 10 different LEDs, which means, by the way, light emitting diode. And you can see the different sliders, and I can play with the different sliders. I can turn off the lights and try to match a specific light, a specific environment. And for example, as today is like St. Patrick's Day, I could turn and boost the green lights to see how this painting could will look like during St. Patrick's Days. And I can then boost the blue LEDs and add yellow and red LEDs to have like a more white light, more like a daylight. And so it's a useful, really useful tool for the conservators to play with, because so we can match the different type of lights and see how the painting looks like. And you can see on the screen here too the spectral power distribution curve of the painting. So if I turn off the lights and if I had each LED, you can see the differences on this spectral power distribution curve. And finally, a last feature pretty interesting is to be able to dim the light. So to be able to play with the intensity due to the change of the daylight, the outside daylight, and to be able to match the different type of lights. So it's one way to interact and to control the lights. And maybe there is another way, maybe an easier way to do that. So Joe?
So hopefully this will work. As I said before, we're filming this on a mobile phone, and obviously most people have mobile phones now. Now the difficulty is if we install these lights in all of the conservation studios, and then a conservator wanted to change the light for whatever reason, they'd then have to give Florian a call, and he'd have to run down the corridor with his laptop, connect them all up and change them. So that doesn't really work. So the company's also provided an app on a mobile phone that hopefully this will work the same way. So at the moment we're sitting on a more daylight equivalent, so I will see if I can swap that to a candlelight. Excellent demonstration of live technology that doesn't work. Okay, so we'll try that one again. So we'll go for, make sure we've got the connection. Yes. So this underpins the complexity of the technology here. Actually, where we're testing them, I don't know if you can move the camera up, you can see that there's a little white box in the middle. Now that's actually a Wi-Fi box, and these lights are on their own dedicated Wi-Fi system, rather than hooked into the normal actually Wi-Fi we use within the gallery. So unfortunately, my phone, being helpful as it is, had reconnected to the National Gallery's Wi-Fi rather than the light's Wi-Fi. So we will try that again now, and there we are, it worked. Excellent. If you do these things in the right order, they will actually work. So we there have the candle light, and if we go to the cool white fluorescent, or we can actually get the daylight. Because obviously the way this works is that if a conservator is working on this and actually wanting to test how the painting will look under different lighting conditions, they want a broad, even light for doing the retouching, but the painting might be going back into a different environment. So our main floor galleries actually are lit with a mixture of daylight and LEDs, but some of the lower floor galleries don't actually have any natural light. They just have the LEDs that we have on the main floor. So effectively, the conservator might want to actually see how the painting would look like when it goes back into the gallery. And that's what this type of light source can actually help us do. It gives us a lot more control for us to explore how best to illuminate the paintings, how best to see the paintings, and how actually to visualize the materials that have been used to construct the paintings in the first place. So we have very high hopes to explore this technology, and it's developing a lot. I mean, it is possible to get much simplified versions of this to actually put at home, where you can just pick very simple colors. But as we're actually looking to try and match specific outputs for specific types of light, like the daylight or particular LEDs downstairs, the technology we have here allows us to match this consistently and controllably and reliably so that the conservators can do the job that they need to do. So hopefully the science, although very complicated, will kind of disappear and allow the conservators to just get on with their job. So I hope that's been interesting for you and illuminating, pardon the pun. And as I said, we're going to be continuing to explore this type of technology over the years and see where we can actually get the best out of it to help members of staff here get on with their jobs. Thank you very much.